Hello, BC Part 1 slash Trig Intro to Calculus. Okay, this is your Columbus Weekend screencast coming at you from Miss Yam's kitchen table. Okay, so as has been the theme of our year, we are going to cycle in and out of trigonometry and other pre-calculus topics, go revisiting old stuff, integrating it with new, etc., right? It's all about the story. It's how about weaving it together and understanding the entirety of the narrative as opposed to discrete chapters, okay? A chapter means nothing without the entire book tying it all together. All right. So I want you to make sure that you are kind of taking notes unique to what your needs are. All right. So if you're looking at this, and especially as you go along with us here and you're taking notes, you want to make sure you're highlighting that which is new or that which is the topic of a screencast. So you'll recall, I'll go to this f of x equals sine x in a minute. You'll recall that negative f of x and f of negative x are also reflective transformations. Negative f of x reflects a function over the y-axis. F of negative x reflects a function over the x-axis, okay? So when I was saying recall, negative f of x does what? F of negative x does what? I just kind of put this here, reflects the function over the corresponding axes that I just said, all right? What we have not done yet is incorporated this transformation into our sinusoidal functions. So here, I give us a task of sketching y equals negative 3 sine. Okay, you can read it here. The only new thing here is that I've incorporated a reflection. And in fact, what reflection would this negative sign be here? Yes, it would be a reflection over the x-axis. Now, here's where you need to be careful, okay? You need to, as you kind of work through the transformations, you have to apply the transformations in obeyance of the order of operations. And in this case, what that means here is that the vertical shift has to happen last, okay? Because up until now, when we've had the combination of transformations that we've had, which have been amplitudes, period changes, stretches or shrinks, horizontal shifts, and vertical shifts, the order in which we did those four transformations doesn't affect the final outcome. Here it does. I mean, you can even do a little mental exercise. If you reflect a function over the x-axis first, and then shift it up 4, right? Picture where that lands, as opposed to taking a function, shifting it up 4, and then reflecting it over the x-axis. So the point is here, when you have a reflection, it matters, the order matters. And specifically, you have to make sure that what you do here last is the +4, okay? So go ahead and try this on your own in steps if you need to, and then replay me to kind of get the final picture. The critical part of these screencasts, if you are to be getting all that you should be getting out of them, all right, is you're making sure you pause when I tell you to pause and kind of engage in the thought process that I'm asking you to engage in at the time. All right, go ahead and try it and then replay me. Okay, so here, if you look at this first, I'm going to first talk you through my thought process. Here I just kind of list the transformations that are happening. I made a little mental note, do last. The first thing, Tyler, go outside. Stop leaving the front door open. Go outside. Do not leave the door open. You're FaceTiming? Okay, then go somewhere else. You're too loud. Okay, so the gray here in dots, all right, that is before the horizontal shift. So what I've done in the gray dotted sketch is I took care of the amplitude, the reflection over the x-axis, and the period. If you look at my kind of gray tick marks. The green is my moving left half, okay? And then, and unfortunately, clearly from my green to my red, it looks like the red has a larger amplitude, but if you look at my markings, it doesn't, okay? Finally, the red is the shifting of the green up 4, all right? So you'll notice here, the amplitude is still 3, it's 4 to 1 or 4 to 7, all right? And here is the final product. So just like everything else, you may find that you're able to, for example, do everything in one fell swoop, right? I kind of broke it down for you here. I think where I'd like you all to be is to be able to do everything in the green in one fell swoop, right? Reflecting a cosine x or a sine x over the axis of the wave is going to require you to remember what the cosine x and sine x functions look like, quote unquote, normally, right? So look at sine x here, it starts middle, it usually goes middle up. Now it goes middle down, right? Middle down, middle up, down, instead of middle up, middle down, middle, right? All right, there's that one. And then here's what I want you to try right now also, okay? Try and sketch this function. And here I kind of use the parent function of y equals root x. And go ahead and try and sketch this one. Notice here, a couple transformations going on. See how the x is negated? Okay, not the entire f of x, right? X is negated. So you have a reflection over the y-axis, vertical shift of 3, vertical stretch of 3, excuse me, vertical shift of down 2, okay? Go ahead and try it on your own and then replay me. And what you've got here is this, all right? My green dots. And again, when you do these in your notebook, boys and girls, too, I urge you just to make efforts to be accurate. You know, I started seeing people using a straight edge really beautifully, I have to say, you know, because the clearer your thought process is, the clearer your work should be. So think of the work you do as a reflection of how you are problem solving. I will also admit right now that on this tablet format, I am not the neatest. I am much neater when it's a paper and pencil format. So it sounds a little bit like the pot calling the kettle black, but mind you that I think I have a valid excuse. Anyway, gray here is 3 root negative x. And you'll notice 0, 0, negative 1, 4, negative 4, 6, right? These are my points that have been stretched vertically by a factor of 3. You know that you are doing these incorrectly, boys and girls, if you find yourself making a t-table. No, no, no. Okay, all these parent functions, like, we should know what this looks like. Okay? And then finally, the red is my final product. Everything's shifted down to. Okay? Very good. A new transformation that you have not seen. Here's a new one. Let's say you have y equals f of x. What do you think the absolute value of f of x would do? And let's just kind of talk this through for a second. This notation here is saying the absolute value of f of x. And maybe some of you are saying, but f of x is another symbol, another notation for y. So the absolute value of y. So this transformation makes every y coordinate what, boys and girls? Yes, it makes this 0 or positive, right? So if you have some function y equals f of x, and you take the absolute value of every y coordinate, any y coordinate that was negative would become positive. So what does that mean? Let's see. Here I just kind of made up a nonsense function, okay? I mean, I did want it to pass through, let's see, 1, 2, this is 4, negative 4, negative 1, negative 3, negative 3, negative 2, negative 3, 0, negative 1, 1, 1, and 2, no, 3, 2, right? Okay, so something like that. Well, let's see. Let's sketch this being, let's sketch the absolute value of f of x right here on this coordinate plane. Well, first thing I want to say is anything where the y value, where the y coordinate is already 0 or positive, is going to remain unaffected because those y values, absolute values, will equal themselves. But look, all of these y values, if I take the absolute value of them, they become positive. And same thing for all of these. And same thing for all of those. And all of those. And what you're looking at here is this in neon green is the absolute value of f of x. So some people like to say, oh, this transformation takes everything below the x-axis and folds it upwards. That's a valid analogy. I think I would accept that. But understand why. What happens here is that, you know, the absolute value of y means that the absolute value of all these y coordinates, so for example, this point here, which was, it was -2, -3, if I take the absolute value of y, it becomes -2, +3, and that's what's happening here. So this is a new transformation for you. And again, do what you have to in your notes to make the new information stand out. Okay? Here's what I want you to do, boys and girls. Please graph the absolute value of cos x. I think it may make you laugh. And then replay me for the answer. Okay, there it is. Okay, now the gray dashed is the parent y equals cosine x, and then the green olive, look at that. Boink, 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 boink. Cute, right? All right, and our final topic for this screencast is this, okay? Blast from the past. I know you saw this in Math 2. Equations of circles where the center is at the origin, okay? They looked like this. X squared plus y squared equals r squared, where r is the radius. So for example, if you had like x squared plus y squared equals 4, you know this is a circle with radius 2, centered at the origin, okay? That's just a blast from the past. I actually didn't know that you had seen that, but, and then I forget who it was who notified me. Oh, you know what it was? I just, I think I just looked at kind of the content coverage for Math 2 last year for your sections. All right, just a recall there. Okay, x squared plus y squared equals 4. I've got to go and double check, or maybe you can tell me when I see you if you've seen equations of circles where the center is not the origin. I'll look into that and get back to you, or you can tell me when I see you next. All right. So what is the problem set associated with this screencast? Here it is. It's all on the screen because I wanted to do specifically exactly what I want to do. I want to do, listen to that comment. I want us to do exactly that, which is what I want you to do. First, these first 4 questions are sketch the following with reasonable accuracy. Okay. Number 1, number 2, number 3. 3 is interesting. I really like 3. Okay. Number 3, I asked you to sketch the absolute value of g of x, where g of x is this. All right. Just kind of bringing us back and cycling us back to possibly old content. And then looking at this one too. This one is an exponential decay function. Just kind of always threading back to the old content. All right. Sketches reasonable accuracy. Boys and girls, please do these accurately. You know, use your straight edge. Make those coordinate planes, right? The clearer they are on paper, the better resource you have when you're studying. And then finally, here's the 5th question. All right. It says x squared plus y squared equals 81 describes a wheel rotating 6 revolutions per minute. A grape smashed into the treads has traveled how far after 27 seconds? And when I say it's traveled how far, I mean as this wheel is turning, right? If your grape is here, after 27 seconds, the grape, as it's making its way around, will have traveled a certain distance around the circumference. That's what I'm asking you to find. How far has the smashed grape traveled in 27 seconds? And question number 5 here is calculator active. And you hopefully that will become evident to you as you start that problem. All right? All right. I will see you on, not until Thursday. All right, have a nice long break from regular school days, and I'll see you soon. Goodbye.